50 million light-years away, a supermassive black hole is creating winds so powerful they're traveling at 10% the speed of light. Welcome to NGC 3783, one of the most violent objects in the universe. NGC 3783 is an active galaxy in the constellation Centaurus. At its center sits a supermassive black hole with a mass of 20 million suns. This black hole is feeding, actively consuming gas, dust, and stars. As material spirals toward the black hole, it forms an accretion disk, a swirling disk of superheated matter. Friction in the disk heats the gas to millions of degrees, making it glow brighter than billions of stars. But here's where things get extreme. The black hole doesn't consume everything. Some of the infalling material gets accelerated and expelled in massive winds called ultra-fast outflows. These winds race outward at 67 million miles per hour, 10% the speed of light. That's 300 times faster than Earth orbits the Sun. The winds carry enormous amounts of energy. In a single year, NGC 3783's black hole expels the mass equivalent of our Sun in superheated gas traveling at relativistic speeds. These outflows are powered by radiation pressure. The accretion disk around the black hole emits intense X-rays and ultraviolet radiation. This radiation pushes against the surrounding gas with such force that it accelerates material to near-light speeds. Think of it like a cosmic blowtorch. The black hole's radiation is so intense, it literally blows away nearby matter. Scientists discovered these ultra-fast outflows using X-ray observatories like XMM-Newton and Chandra. They detected highly ionized iron atoms in the outflowing gas. Iron stripped of most of its electrons by the extreme radiation environment. The presence of ionized iron is a signature of ultra-fast winds. The atoms are moving so fast that their light is Doppler shifted, stretched toward bluer wavelengths as they rush toward us. Why does this matter? Because these winds change galaxies. Ultra-fast outflows regulate star formation. When the black hole expels gas at light speed, that gas is no longer available to form stars. Over millions of years, these winds can shut down star formation across an entire galaxy. This process is called AGN feedback, active galactic nucleus feedback. It's one of the most important mechanisms in galaxy evolution. Without AGN feedback, galaxies would form stars too quickly and burn through all their gas in a few 100 million years. The winds from supermassive black holes slow down star formation, allowing galaxies to evolve over billions of years. NGC 3783's winds also create shockwaves. When ultra-fast outflows collide with slower-moving gas in the galaxy, they create massive shock fronts that heat and compress the surrounding material. These shocks can trigger new star formation in some regions, while suppressing it in others. The interaction between black hole winds and galactic gas is incredibly complex. But here's the nightmare scenario. If you were somehow near NGC 3783's accretion disk, the radiation alone would vaporize you instantly. The X-rays and gamma rays are so intense, they'd strip atoms apart. And if the ultra-fast winds hit you, you'd be accelerated to 10% the speed of light and flung into intergalactic space, probably as ionized plasma. NGC 3783 is a Seyfert galaxy, a type of active galaxy with an extremely bright nucleus. It's one of the best studied examples of ultra-fast outflows because it's relatively close and unobstructed by dust. Astronomers continue studying NGC 3783 to understand how supermassive black holes shape the galaxies around them. The winds we observe today have been blowing for millions of years, and they'll continue for millions more. NGC 3783 reminds us that black holes don't just destroy, they create. They regulate, they shape the evolution of galaxies across cosmic time. Like, share, and subscribe for more extreme cosmic phenomena. And as always, keep looking up.